So in the last short video, we learned how to calculate work. So today we're going to take work, we're going to calculate it over a greater period of time, and then we're going to be able to calculate the power output that the person is doing on the bike. So, first question, how much work is done, for example, in 30 minutes given these variables? Well, the first thing we have to establish is the formula. Work is equal to a force times a distance. To calculate force, we need to know both the mass and the acceleration on an object. Now, when we're talking about a bike, we're talking about ergometry. The mass is also called the resistance, or the load that's put on the bike. And that load is pulled down by gravity, and that applies pressure to the wheel. So, in this case, the mass is a 1.5 kilogram load placed on the bike. We multiply that by the effective gravity, which is an acceleration of 9.81 meters per second squared, and the result is 14.7 newtons. Next, we need to calculate distance. So again, when we're talking about an ergometer, and that ergometer is a bike, we need to know the size of the wheel and the number of times the wheel turns. So, distance is then calculated on a Monarch bike, which has a 6-meter wheel, as 6 meters per revolution, times our cadence, which is RPMs, revolutions per minute, in this case 100, times the amount of time. Now, in the previous example, we used 1 minute, but in this case, we know that they've been pedaling for 30 minutes, so we have to multiply this by 30 minutes. Looking at the units, they cancel out, so revolutions on the bottom cancels with revolutions on the top, minutes on the bottom cancels with minutes on the top, and all we're left with is meters. Now, 6 times 100 times 30 is equal to 18,000 meters. 18 kilometers. And that makes sense. If you're pedaling for 30 minutes, that you would travel 18 kilometers. Now, we know the units for work are going to be Newton meters, so we don't want to turn that into kilometers. We leave it as is, and we calculate work. Work is equal to 14.7 newtons times 1,800 meters, or 264,870 Newton meters. Now, if you remember, we can also express Newton meters as joules. Or we could even express it as kilojoules, 264.87 kilojoules. But we're going to leave it as is right now, because the next thing we have to do is calculate power output. So, power output, once we've done all this work, is very simple. Power output is equal to work divided by time in seconds. So an important thing to clarify right now, do not confuse time in seconds with the power output equation with time in minutes in the distance equation used for the Monarch bicycle. So, in this case, our work, which we've just calculated, is 264,870 joules. We divide that by, how many seconds are there in 30 minutes? Well, 30 minutes times 60 seconds per minute what we can determine, and we'll simplify it one more time, is that that equals to our work divided by 1,800 seconds. The solution to which is 147.15. So again, we have an option. We can call these joule seconds or watts. So the answer would be 147.15 watts. Now, an interesting thing about power output is that power output is the same during the first minute of that bike ride as it is during the last minute of that bike ride, as long as the resistance and the revolutions per minute stay the same. So a trick you can use when calculating power output, but not when calculating work, is that you can always calculate power output and get the same answer if you assume 1 minute of time. So over here, let's take a look at the formula and let's do that. Power output is equal to work over time, which we can expand is equaling work is equal to force times distance over time. And we can expand that one more time. Mass times acceleration times distance over time, which is a handy formula to remember because it allows you to remember the formula for work as MAD, MAD. It also allows you to remember the power output, which is work over time, so the rate of work. So let's take the same example and calculate it for 1 minute. What we find is this. So mass is the same, 1.5 kilograms. Gravity is the same, 9.81 meters per second squared. But when we calculate distance, the size of the wheel is the same at 6 meters. The cadence is the same at 100 revolutions per minute. But our time is now only 1 minute. Let's just cancel out some units right away. So we know that minutes and minutes are going to cancel and revolutions are going to cancel. So we're left with nothing but meters. So our distance calculation is going to work. And we divide that by our time. So now we're not using 1,800 seconds because we're using only 1 minute, which means we only have 60 seconds. And what we'll find is the answer is the same at 147.15 watts. So what you have to do is practice both of these. Because if you're asked to calculate work over time, you have to know how long they were working. But if you're asked to calculate power output and you want to simplify the math a little bit, you can assume only 1 minute has taken place.